This is Kulali and her owner Garth. Garth was a successful engineer who started building Kulali as his final life project. Unfortunately, Garth never got to see her finished. I've been lucky enough to take the challenge on of completing her build and one day to sail her around the world. Similar to Garth, I'm a passionate engineer who loves to know how things work and how to build things. Join me on this journey to bring Garth's dream to life. This is Sailing Kulali.
Welcome back to another episode. I've machined up this bottom bearing housing and this top bearing housing and the sealing tube. And today I'm going to cut from this umpy rod. What's going on in this focus? From this umpy rod. Jesus. From this umpy rod, I'm going to cut the 80mm or 90mm bearing blocks from it. So it'll be the biggest part that I put in this little lathe. So let's see how it goes. Alright, so now that the part's inside here, the umpy stock, we're going to now measure and try and just mark 90mm. The bearing's going to be 80mm, but I'm going to go 90mm just to give it a bit more room. I won't do a parting operation on it because it's just dumb, and I'll just use a like a saw or something to cut it. We'll see what happens. Alright, so I've marked with the lathe two 100mm pieces here, and I'm going to cut it with a cold cut saw now. I think I tried cutting it with a hacksaw, it doesn't work. So let's see. So it doesn't look like it's going to fit in the clamp, in the vise. I'll just clamp it down. Yeah. So I'm going to take one of these chucks out. That should make it fit a bit nicer. Put that up. Far out, that was hard to cut. Look at this stuff. It's tougher to cut than metal, I think. Alright, there's been a bit more progress today. This and this is done. So that's pretty much waiting for these bearings to be cut out. That was pretty hard to cut, this bearing. Almost, I would say definitely harder than steel. I don't know. Nah, I guess a steel solid rod wouldn't be that hard to cut. Or wouldn't be that easy to cut, but a bearing's going to be made out of that to go inside here. Cool. Worst cut in the world. Alright, welcome back to another day of sailing Kulali. This is the rudder post and rudder bearing housings ready to be welded together and bored out so that the bearings, which are these umpy blocks, will be machined and pushed into there as well. So we're getting pretty close. It's an exciting day today because some mail rocked up today, some sponsor mail. It's not actually sponsored mail, it's from eBay. And it is, look at this. Yes. These are boring bars. Boring bars. They are used to bore. Look at this, look at this. So that's a boring bar. A carbide insert goes on the tip of that, and that bores the inside of your workpiece out. So it's the first time I've ever bored anything, so let's see what happens. So job 1, locks. 2, turn OD. 3, 4, turn round. 5, fit bearings. So we've done some little step by steps, done the calculations on the bearings. So I'm going to make this first, I'm going to bore this out to 99.4, which is going to be the outer diameter of the bearing. So that's the first step. That's 0, and it's going up quite a lot. So that means this side needs to go down. So same thing with setting up a boring bar. Apparently you still want to get it centered. I think there's like some debate whether you should have it above or below center line, but so yeah, something to do with chip clearing and all sorts. I don't really know how to line that up. Oh, I can just turn this a bit more. That's an idea. I'll turn that. Like that. So that's been shimmed now. And that's pretty much bang on. It could probably come up 1 more mil, but I'm happy with that. Alright, so this ID in here is currently 88 millimeters, and we want to bring that out to the OD of the bearing, which is 99.4 millimeters. So that means I need to take 11.4 millimeters off. That was pretty easy math, wasn't it? 11.4 millimeters off. So I need to come across this way by 11.4 divided by 2. Divided by 2, which I need a calculator for that. No, I don't. 5.5 plus 0.2 is 5.7 mil. We need to come across 5.7 mil. So this is probably the toughest lathe operation I've done to date. Basically, we're going to bore this out so that the bearing can fit in here, but we want it to be 15 mil short of here. So I've marked this feed whatever indicator to stop at 15 mil below there. So we'll do that. Alright, so that's hot off the press. You can see the step that's been machined in now to take the OD of the bearing. But now what I want to do is I want to make that step down the bottom there where it joins the same rough OD as this tube here. Idea being there's no reason for that step to be there. I just wanted to make sure there's enough material to weld to this part here. I don't think that makes sense, but okay. So just to explain the process a bit more, that was the bearing ring, bearing housing. So a few processes involved there. That's the step where this becomes concentric, so that locks in as such. So
So this is the other side of that, and we've machined that down to give a opening for the soon-to-be bearings. Alright, so that's been flipped around. You can see the step in there. So we don't want that step to be that pronounced, so I'm gonna take that back, bore that back with the boring bar, and then the tube, the rudder tube, will fit into that perfectly. Not perfectly, there's no such thing. Alright, so that step's machined down quite a lot now. That's to 93. This, because it's an extruded pipe, is 93 to 94. I did it at 93. So if I put that on there, then you can see there's just a slight step. So that's the step with some light. It's probably about a 1/2 mil step, which is fine. Alright, so that's one bearing housing pretty much done. So now I'm going to do the same thing to this one. So you can see here why you have to machine the pipe instead of just using it. So because it's extruded, the pipe doesn't come out exactly round. So you can see that stripe there is where the lathe hasn't even come in contact with it as we're machining it. So imagine an oval, you're only taking away the shallowest part of the oval, and that's that point there. Alright, that's the second one done. You can see there's a height difference between this one and this one, so I'm going to machine that one down a bit to make it even, so that the bearings will be the same. Otherwise it'll get confusing. Let's do that. Alright, bit of a learning curve. Added numbers to the chucks. I saw this in a video, but basically every time, because it's a 4-jaw chuck, it's hard to keep concentric. So I'll now always take off number 1 and number 2. And what that means is when I put a part back in, the same part, I just tighten 1 and 2 up again, and then it's concentric or very close to it, and then it's easier to dial in. Yeah, tip. Alright, so these are both the same height now, give or take probably 0.1 of a mil, which is pretty good tolerances. So those are the bearing housings done. So what's exciting is this goes on there. It pretty much lines up perfectly when you go like that. And then the other one goes on like this. Boom. Done. And so because that's been machined, these two faces have been machined, and these two, when I butt that up and bolt it together, that should mean that this axis is the same as this axis. So there shouldn't be much more adjustment or alignment there. So now I'm going to start working on the bearings. I'm going to face each of these off and then start working out how they go together. Those are some big chips. Look at those chips. I think the feed speed needs to be increased quite a bit, but it's alright. Let's just see what that comes out like. Little pancake. It's a pretty amazing material, this ultra high molecular weight polyethylene. Like, it's just so strong. I can't believe that I took a 0.5 mil cut off there, or maybe it's a 1 mil cut, but I just can't believe, you know, normally a material would chip, but this, I guess that's why it makes such a good bearing material, how tough it is. Amazing. And that surface there, unbelievable. The finish, look at that, it's so light, really good. So that's the cut bearing block, and that's a machine bearing block. Now that's the bearing, and so the idea is that I'm going to make this fit into this hole here, like that, and then once that's in there, then my plan is to machine that bearing out of there with it in here to hold it in place. That's the idea. Not sure if it's going to work because it might spin in there. Probably heat this up before I put that in and then heat it up to get it out. I don't know. Yeah, try it out. Alright, so the idea is that I need to machine this down to 99.4 OD and 63.4 deep. Alright, so that bearing block has been machined. There's a little radius in here, so it's a bit curved. So I'm just going to knock off the edge of that so that that will sit flush. You see what I'm saying? Because if that radius is there, it's going to clash with that sharp point. There you go, chamfer's on. Alright, so 2 bearings. This one has the chamfer on it that I just put on. This one doesn't. And there's 1 bearing done. There's still 1 more to go. And this, I'm going to heat up the bearing, this block here, just in hot water, up to about 40 degrees, or boiling water maybe. And I'm going to try and slide that on. Okay. Need it clean though. Pretty happy about that. So we'll let that rest for a little while in there.
All right, so we've got the thing in there, like one of these in there heating up. This is the bearing blank that's been made out of a cut bit of bearing rod. And this diameter here is exactly the same as this diameter here, but because there's surface roughness, it won't go in that easily. Like it will, you could hammer it in, but what I'm going to try and do, I'm going to heat it up so it goes in easier, but I probably will use a mallet to put it in. It's been about, it's 8 o'clock now at night, I think. Yeah, 8 o'clock, and it's been, so that means it's like 6 hours of lathe work to get to this stage, and then there's 1 more bearing to do, and then we're pretty much done with all the bearing system. Let's see what happens. Woo. All right. Here we go. So that's very hot, 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 hot. And let's see how this goes. Oh. Oh. That was smooth. So it spins now, and let's see when it cools down whether that still spins. But that's really, I'm really happy with that. That means the fit's really good, all the measurements came out really good. It's buttered up at the bottom of that perfectly. See that? At the bottom of that. That's, couldn't ask for more, couldn't ask for less, couldn't ask for whatever. So the idea is now that is going to be the bearing that's going to go back in the lathe, and then we're going to turn out the bearing out of this, so there's going to be 5 millimeters of space in there. Yeah, so let's see what happens. See, that's already starting to tighten up. Yeah, so it's been about like less than 5 minutes, and that I can't turn that anymore. So that does mean that aluminium is shrinking around this, which will make it a compression fit. So the only thing I need to think about is I'm going to have to weld this onto here, like that. And obviously I can't weld the bearing in, so I'm going to have to get this bearing out after I've cut it out. Yeah, cool. So the way that you would install a new bearing inside the boat would be to dry ice this, and I got to check the expansion, thermal expansion of these, but yeah, I'm pretty sure it's pretty good. But yeah, there we go.